Hi, everyone. So I'm Jan, and this is Peter. We both work at the Electronic Frontier Foundation, although I'm a mere lowly technology fellow, and Peter is the chief computer scientist. So today we're going to be telling you some scary bedtime stories about the encrypted web and how Let's Encrypt is helping make things better. So how many people here have heard of Let's Encrypt? I barely see anyone whose hand isn't up, which is great.
How many people have used it?
How many people have used it?
A few of you. Cool.
Fewer. Cool. So horror story number one, I'm sure is familiar to everyone here. It's that we don't yet live in a 100% HTTPS world. In fact, a few years ago when I logged into Quora, which at the point had like 10 million users or something, they were sending my passwords over plain text. Oh man, yeah, everyone booed them. And then I didn't use it since 2014. But I did check and it's fixed now, right? So, but some sites are not Quora, right? They don't have engineering staff. And so if you're a small website operator, setting up TLS today is still tedious. Just to give you an example, this is a screenshot from the DreamHost wiki on how to set up HTTPS. They've actually made this process a lot easier recently by integrating Let's Encrypt. But before that, you had to go through this like 12 or 14-step process and make sure you weren't accidentally copying and pasting your private key into your web browser, et cetera. And a lot of people do mess that up. So let's assume you've gotten a cert finally, right? Then you might find that TLS configuration is really confusing. So as crypt analysis gets better, we discover algorithms like RC4 are no longer secure. People like Nick Sullivan at Cloudflare write these great posts that are like, hey, server operators, it's time to turn off RC4. And unless you're keeping up to date with the latest TLS best practices, you may not realize that your server is now vulnerable.
Right, we can't all be hitting refresh on Nick Sullivan's blog every day.
Although I do, so, it's, yeah. So, and similarly, SHA-1 is being deprecated by browsers, and so you have to go and make sure you get a SHA-256 cert chain, and all that. But this is solvable, right? Like, what if we could all just use good TLS configurations? And this is actually a problem we'll talk about how Let's Encrypt is solving. But basically, there's there's books you can go out and find. There's wikis about like the best TLS configurations at any time. So what if you could just push that to all the clients who need to upgrade and so forth? Okay, so let's assume now you've set up TLS, and finally you're ready to switch your site over to HTTPS. You type in nginx, sreload, etc. And you go to your site, and it's horribly broken because of mixed content blocking. Mixed content blocking is where you've switched your top-level site, Lenovo.com, over to HTTPS, but you're loading these images and scripts and iframes and all these ads and other resources over HTTP because those sites don't yet support HTTPS. So the browser's like, no, we're in a secure mode. We don't want to pollute that with insecure HTTP. So we're just going to block those HTTP resources. So as a result, scripts aren't running because those are getting blocked, and your site just looks completely broken. This is actually a very large reason that new sites aren't able to switch to HTTPS because they're using ad networks that don't support HTTPS yet. So last year, the W3C said, we're going to fix this. Well, we're going to try to fix this by adding in a new content security policy, HTTP header. So for those of you who aren't familiar, this is just an HTTP header the server can say, the server sends, and it says upgrade insecure requests. And when a browser sees this, it starts just automatically trying to fetch the HTTPS resources. It still blocks them if HTTPS isn't available. But I actually had to use this a few days ago because I upgraded WordPress, and my blog, just like all the HTTPS links, were converted back to HTTP by the updater somehow. So I freaked out, and then I fixed it in 20 seconds because I just set this header, and modern like Chrome and Firefox users, their browsers would just say, oh, these resources, we should just try to upgrade them. So my blog looks amazing again. So. And finally, I'm sure this is a familiar story to many, but there are a lot of certificate authorities out there. So Peter, how many certificate authorities do you think there are?
It's actually kind of hard to tell, but the number from a scan that we did maybe 5 years ago, late 2010, there was something like 1,500 certificates that could make CA certificates that could sign something for google.com or facebook.com, and your browser would trust it. Probably controlled by somewhere between 200 and 400 organizations, but it was very hard to count.
Yeah.
So it's time to fight back against the unencrypted and insecure web. Let's gather our forces, go out into the night, and confront these demons that we're up against. We decided to try and address this by starting a CA. Basically, there are too many of them, too many CAs out there. Let's make one that's a little bit more friendly and use it to do things better. So it's called Let's Encrypt. It's free. It's automated. It's open. Both the code and the data is open. It's in public beta. You can use it today. It was created as the merger of two projects. There was a project at EFF and the University of Michigan and a project at Mozilla. We joined forces. We got a lot of financial assistance from Cisco and Akamai. We got our CA cross-signed by an existing CA called Identrust, which means that it's compatible with older browsers. And it's housed in a new 501c3 called the Internet Security Research Group, or ISRG. We've been getting more sponsors since we launched. This is the current list. If you are thinking about it, please come and sponsor ISRG. Help us make this thing bigger and more effective. Now, fundamentally, when you run a CA, you're going to have to make this really important decision. Every time a website, a server comes along and asks you, hey, can I have a cert? You have to decide, is the answer yes or is the answer no? And the way we do this, looks something like a scene from the Monty Python and the Quest for the Holy Grail. We're kind of the knights who say knee. You come along and you say, can we have a cert? And we say, bring us a shrubbery. And then you come along and maybe you bring us a shrubbery, and then we say, well, bring us another shrubbery. And the protocol for this conversation is called ACME. It's a new proposed standard at the IETF. And the shrubberies are called challenges. And they're sort of an extensible set of things that a server can do to prove that it controls a particular domain name and therefore deserves a certificate for that domain name. We currently support a challenge over port 80, where you put up a file at a special well-known URL. We support a challenge over port 443, where you put up a synthetic certificate on a synthetic domain name in a TLS connection. And we support a DNS challenge, where you put a record in your DNS entry. We may support more challenges in the future. Now, this thing launched quite recently, private beta in November last year. Public beta, open to anyone without a sign-up in December. As soon as we did that, we were starting to issue a lot of certificates, one cert every 3 seconds. In the first little while of public availability, we're at close to 400K certs now. This is the graph. If this keeps growing like this, we'll be doing a large fraction of the HTTPS web within a year, and we're hoping that the graph will actually get steeper as large deployments start to integrate. Now, some more statistics. If you go and look at the things we've issued in the certificate transparency logs, because we publish all of the data about what we're signing, if you scan all of those domain names, you'll actually find that there are 547,200 domain names right now that are answering with one of these certificates. More than the number of certificates, because you can get a cert that has multiple names in it. About 85% of these names have never spoken HTTPS before. So we are helping a few people who already have TLS and a whole lot of new people who've never been able to do it before. And we feel like we're winning here. There are also quite a lot of certs that aren't being served yet. That's a combination of people playing around with the thing, people playing around with automating renewal, people taking certs and putting them up on SMTP servers, IMAP servers, other kinds of mail servers, XMPP servers, whatever you want. You can use these certificates for any protocol that uses TLS, and some people who probably are not serving a public service on that domain name. We're doing not too badly on the Cypher Suite front. If you look at the machines that are answering connections with these certs, they look like they're speaking, by and large, modern ciphers. There's predominant forward secrecy on these machines. It looks like in this place, we're winning against the forces of darkness. This is, of course, forward secrecy is super important if, as the Snowden revelations showed, you have a whole bunch of adversaries who may do things like steal your keys. You want to have your connection safe against those kinds of attacks, or at least somewhat protected. There's some deployment starting to happen inside the top Alexa domains. We wouldn't really have expected that at all yet. To be honest, we're still in beta. We've only been out for 2 months. It's a little bit crazy to be using us on a really important high-value production service, but we expect that to actually become less crazy as we come out of beta and have been able to demonstrate good uptime and reliability over the next months and years. Now, deployment of these certificates and getting them actually installed on web servers is kind of a layered problem for the web. If you look at this, we're cropped at the bottom, but you can think of the web as being sites as being a combination of different types of hosting. At the bottom, you have cheap hosting where you don't necessarily have a shell of any sort. Maybe you have a WordPress instance that's hosted by someone for you, or you have an FTP upload that you can make to some directory somewhere, or you have a Facebook page or a Tumblr page or something that's basically provided for you. Then the next layer up, you have people who run their own servers in some way. Maybe they actually have a physical server, more commonly perhaps a VPS of some sort, like Amazon or DigitalOcean. Or you can have managed hosting where someone will rack a box for you and you run your websites on that. Going up the stack further, you start to get sites that have multiple web servers with some type of load balancing or round robining around them. Then you go up another layer and you hit the Googles and the Facebooks of the internet, people who have very, very large and sophisticated server infrastructures. Now, it's actually kind of a different problem how to get Let's Encrypt in use in each of these layers. We kind of want to be used by all of these layers where appropriate, but they're going to take different solutions. So we have a client that we have been shipping. It's basically an EFF and open source project, the Let's Encrypt Python client. We're probably going to be actually officially branding it as an EFF thing in the coming months. It is intended primarily to serve this single server case. People who have a Unix machine that they can log into, they serve a website off that. It is capable to some extent of handling multi-web server deployments, but isn't primarily designed for that case. There's separate work to be done for the people who are in the top and bottom tiers of the cake, where they basically need to have some operator of those hosting platforms implement their own version of the Acme client or use an Acme library to deploy across at the bottom layer, the millions of websites that they have there. The top layer, it might be a million servers answering for google.com. So these are all separate cases. We have these diverse clients speaking the Acme protocol already. There are over a dozen clients out there that you can choose from. If you look at the ones that are issuing, broken down right now, this is the last 2 weeks. About 70% of the requests are coming from the fairly fully featured and complicated Python client that we have. And then you have a spread of different requests coming from these other clients. This is really cool. One that's worth mentioning is Caddy. Caddy is a web server that has a client for the Let's Encrypt protocol, the Acme protocol, built into it. So it'll just automatically obtain a cert anytime it's serving a domain name. That's probably, in the long run, the place we want all web servers to be, but it'll take 3 to 5 years before we could imagine an Apache or an Nginx having that on by default in all of the places where it's running. And so the Python client is a solution that's available in the meantime for people who need it. If you dive in and say, OK, within this 70%, what does it look like? Who are the people who are running this? What platforms are they running on? You get incredible diversity again. There are over 20 operating systems that have significant market shares in there, mostly Linuxes, but there are BSD and Darwin in there as well. It's also worth noting, this is kind of a little terrifying, but a lot of these are really old operating systems. Ubuntu 14 and Debian 8, not so bad, but we have giant chunks running Debian 7, Ubuntu 12, CentOS 6.5 and 6.6. Debian 6 is close to 1%. Still, it's not actually in this graph, but it's pretty large. And so we have to confront the fact that people are running web servers that have old versions of Python, old versions of Apache, and so we're doing quite a lot of work to make sure that our code runs decently well on all of these platforms. It's a lot of fun. And this Python client is sort of a Swiss Army knife. It's intended to be able to run on all of those platforms and to do an increasingly good job of just automated end-to-end deployment for all the cases that people have. And this is daunting, but we're making pretty rapid progress on it. So the way it works internally is it has these plugins that you can use. It has two important types that are worth talking about. An authenticator that's basically a thing that produces the shrubberies and passes the challenges to get a certificate. If you want to make one of these things, you just need to implement the little three-function Python interface that I've got on the screen. We have maybe 4 or 5 implementations of that are pretty widely used already, and people can make more of them. And then we have the second interface if you want to hook a TLS server into it and automate installation of certs. You can implement this slightly longer set of functions, which include things like rollback. If you've made a configuration that tries to install a cert and then there's a problem with it, you've got to guarantee that you can revert back to the state that you were in beforehand so you don't break people's servers. It handles requests for enhancements like upgrade insecure requests or HSTS or redirect from HTTP to HTTPS, all of these things. And if you look in deployment, what are people using? They're actually already using quite a lot of these plugins in diverse modes. We ship the Apache WebRoot and standalone and manual ones. The Plesk one's a third-party one that's already, this is data from the last 2 weeks. Thousands of people in a 2-week period were using the Plesk plugin on Ubuntu 14, so it's getting real usage. We have an Nginx plugin that's in the works. We're not shipping it yet, but there's a team at ThoughtWorks that's trying to get this into MVP state, and when it does, hopefully we'll see that popping up right up here, and the Swiss Army knife is working for all the different diverse operating systems and web servers that people are trying to deploy certs on. How well configured are we? Jan talked about some of the daemons we confront here. People, I'm sure you've seen talks earlier in the conference about the other things that can go wrong. We're not doing too badly. The daemons are here. You can see the classic ones like incomplete chains or incorrect names, so you haven't configured your SNI appropriately. But these are small percentages. By and large, when people get a cert from us, either our automated tools or the configuration instructions we give them, these are working fairly well. But we do have these features we know we want to deploy, and some automation might get us further on these.
Great. So nothing ever ships without vulnerabilities, as you all know. So Let's Encrypt, for what it's worth, is fully open source. So this is the GitHub issue tracker from Boulder, which is the Let's Encrypt certificate authority server that issues people certificates. So you can see there's like, this isn't even a complete list. I know there's like an issue Chris Palmer found and some I found that aren't on this list. But people have been opening bugs, although most of these are from our own team. So I'll give you 2 examples of security vulnerabilities that were reported by outside contributors. So the first one was from Andrew Ayer in last August. So note that this was before we shipped, and this was when we were still like working on making the client usable and revising the draft of the Acme spec and all that. But basically, he found an attack that would allow misissuance. But we hadn't shipped then, so we actually fixed this before shipping. Basically, how it works is that an attacker, which we'll call Mallory, wants to get a certificate for example.com, and she says, "I'm going to do that via DNS, the DNS challenge. That's the shrubbery. Is you have to put something in DNS that proves you own the domain." So she goes through this protocol where she registers an RSA key pair with Let's Encrypt to sign the challenges that Let's Encrypt gives back to her. So Let's Encrypt's like, here's your DNS challenge. Go get a shrubbery, and then. So in this situation, example.com had already used Let's Encrypt with the DNS challenge. So example.com had provisioned a DNS TXT record with its own challenges to get a certificate. So what Mallory does something very clever in step 4, where she goes to example.com and gets example.com's TXT record, and she constructs an RSA key such that she can make the thing in 3 a valid signature over the challenge she was issued. I'll explain this a little better the next slide. But basically, once she's constructed that special malicious RSA key pair in 4, she says, hey, Let's Encrypt, I've actually lost my original account key. Can you use this new key? And Let's Encrypt's like, OK, cool. And then Let's Encrypt goes to example.com and checks that that DNS thing is a valid signature with the key that Mallory just gave her. That was a mouthful. But so this was really clever. It was like a series of really cool tricks that led to misissuance that was kind of subtle. But as Andrew points out, there's a fundamental problem, which is that we had been assuming that a signature uniquely identifies a public key message tuple, but that's not mathematically a guarantee of RSA. So this was fixed in September by, I think this was Richard Barnes. We decided, OK, why are we even putting signatures? Like, we can just put the challenge token in DNS directly with the public key of the user, right? So the first vulnerability that we got was reported in production was in December. So this was shortly after we went live in public beta. But someone basically found that we weren't really checking CAA records, which can say like, the domain owner only wants to be issued certificates by certain CAs. So because of this, we had misissued 6 certificates. But this was fixed. It was reported at like 10 a.m. and it was fixed by 1 p.m. on the same day. But yeah, it's an ongoing process. We actively work to address these things. So what haven't we solved yet?
So one problem we talked about before that we haven't solved yet, unfortunately, is mixed content. There is this upgrade insecure requests header that we were hoping was going to be the magic cross you could hold up against mixed content problems. Maybe not in all cases, but in the cases where there was some way of getting to the resource, if it was a script, this would help. The problem is it does help for JavaScript, but it actually is hurting us for images. So right now in a browser by default, if you're HTTPS, the scripts will get blocked if they're HTTP. The images will be let through as kind of a like, well, it's not great that they're HTTP, but the images can't actually steal your password and post it to some other URL, so we'll let them in. This header, as it's kind of been deployed, is fixing the JavaScript problem, but actually blocking a bunch of your images if they happen to not be upgradable. So you wind up, there's a demo at this URL where without the header, everything looks fine. With the header, you fix the JavaScript, but you break the images. So we're going to work on trying to get this fixed at the W3C. The other thing that we can do is potentially use some kind of CSP reporting mechanism to generate a data set for site administrators saying, hey, here's all the pages on your website where you have some kind of mixed content problem. And here's maybe in some cases a way to fix them using HTTPS Everywhere rules. The problem is this header exists, the technology's out there, but we need to have a web server somewhere that collects all of the reports for all of the mixed content that's being audited, and doing that in a privacy-friendly and scalable way and giving people the reports they need is going to be tricky. So this is stuff we're going to be working on in the coming months. If you'd like to help, you can help us with the spec, with this Python client, the fully featured one, or any of the alternatives if you want a simpler, smaller one, and the server code. It's all open source. Come and get hacking with us.